Okay, good morning everyone. So at this time, we will talk all about basic calculus, particularly on problems and solution for the topic which is related rates. So this is actually the application for derivative, so related rates. So what is being presented in this topic or in this video will be about problems and solution for the related rates. Okay, so let us now proceed for problem 1. The first problem. A ladder is 12 meters long, is leaning against the wall of a building. The bottom of the ladder is sliding away from the wall at the rate of 1.5 meter per second. How fast is the top of the ladder sliding down when it is 3 meters above the ground? So in this problem, so there is a ladder, no? The ladder wherein it is 12 meters in long. So it is being leans against the wall, and at the same time the bottom of the ladder is sliding away from the wall at the rate of 1.5 meter per second. So this quantity, which is 1.5 meter per second, is referring to the change, no? The change of what? The change of the distance when the ladder sliding away from the bottom of the away from the wall, no? So 1.5 meter per second. So with respect to time, so it means that because that one is referring to the horizontal, the horizontal line, so that 1.5 meter per second is referring to dx over dt. So dx over dt is 1.5 meter per seconds. So what is being asked in this problem is that how fast is the top of the ladder sliding down when it is 3 meters above the ground? So what are we going to do for this problem is we are going to identify dy over dt, meaning the change of what the distance from when the ladder will sliding down, no? Slides it down, paubos, so meaning that is with respect to y, so the change of the distance along with the horizontal line, so dy over dt. Provided that the ladder, no, is 3 meters above the ground, so meaning its height, no, katong lens niya against the wall. Okay, so first is let us have an illustration regarding this problem. Okay, so we have here the solution. So the first one we have here, this one is referring to the wall kaning a figure. The second, we have here the ladder, that is actually, so another figure is sliding down. That is what is being asked in the problem, no? dy over dt, because we are focusing on, we are finding on the change, no? The change in distance with respect to time when the ladder will slide down. Okay. So also we have here the ladder is 12 meters long. Another quantity given is we have here the ladder is 3 meter now from the ground. So young height now 3 meter. Next, okay. So we also have another quantity from the problem that is being described, that the change in this distance with respect to time for the horizontal line wherein the ladder will uh, when the ladder will, okay, go away from the wall, no, with respect to the horizontal line. So we have dx over dt is equal to 1.5 meter per seconds. Next, as what we observe also in this figure, this one is referring to, or this one is, we can represent this figure using the Pythagorean theorem, no? So we have x squared plus y squared is equal to z squared. It means that the square of the hypotenuse is equal to the sum of the square of the two legs of one right triangle. So the Pythagorean theorem can be used to model this type of problem at the same time solving for some unknown quantities. No? Okay, so from that, we know that the z squared is referring to 12 meters, the z rather, but when we are going to square that one, so it will become 12 squared. So x squared plus y squared is equal to 12 squared. or x squared plus y squared is equal to 144 because 12 to the power of 2 is 144. Then we can now solve for x because we know that the value of y is given, which is 3 meters. So we can now have x is equal to 144 minus 3 squared, no? Then the square root of this given quantity, no, nalimutan ako butag square root, but there must be a square root of 144 minus 3 squared. So the result would be 11.62. Okay. After that, from the given also equation, x squared plus y squared is equal to 144, we can also have y squared or transpose x quantity, no, to the other side. So we have x squared is equal to 144 minus x squared. Then after that, because what we're going to identify is the change in distance with respect to time along with the horizontal line. So we can now identify the derivative, no? So the derivative of y squared is 2y. Then after getting the derivative, we can now write down dy over dt. The reason is that the change, kanang dy over dt is referring to the change of distance with respect to time. No? Remember also that the derivative of any constant is 0. So we have derivative of 144 is 0 minus the derivative of x squared is 2x. Then we have to write that also dx over dt. After that, we can divide both sides by 2y because what is being asked in the problem is dy over dt. So that the left hand side will have this quantity dy over dt. Okay, so dividing both sides by 2y, we can now have dy over dt is equal to negative 2x times dx over dt over 2y. So at this time, we can now use those given quantities now for dx over dt, the value of x, and also the value of y for us to get the value of dy over dt. So we have here dy over dt is equal to negative. We have 2 times the quantity of 11.62 meters. 11.62 is referring to the value of x actually, no? As we get the square root of the difference between 144 minus 3 squared. So, kuha to yung square root, that is 11.62. Then multiplied by dx over dt, that is referring to 1.5 meter per seconds over 2 times 3 meter, wherein y is equivalent to 3 meters. Then simplifying that quantity will give us dy over dt now is equal to 5.81 meters per second. So therefore, in every second, we have 5.81 meters iyahang distance now na mag-slide down ang ladder from the wall. Okay? Okay, let us have now the second problem. Problem number 2. A man is 180 cm tall, is walking away from a street light. Uh, Given that 6.1 meters high ang straight line at a rate of 120 cm per second. So we are asked to find the rate at which the length of his shadow is changing. Now, as he walk away from 6.1 meters high, no, of the street light. Okay, so of course, let us have first the representation of this problem. No? Okay, so we have here the vertical, the horizontal line, and also the hypotenuse. That is referring to the right triangle. So that vertical line is referring to the straight line, no, that is 6.1 meters high. Okay. Okay, another horizontal line next to the longest one, which is the 6.1 meters high. We have here that is referring to the man, which is 180 cm tall, no. Okay. So we have to convert also 6.1 meters into cm. So we are just going to multiply that one by 100. So 6.1 times 100 is 610 cm. Okay? So we have 180 cm. That is not meters supposed to be. That is cm. So we have here x. That is along with horizontal line. Then we have here another one is s. That one, that line from s, okay, is referring to the shadow of the man, no, walking away from the straight line. Okay, so that is the quantity, or that length is that only length na is that we are going to identify for this problem, no? The change in his shadow, okay, the length of his shadow. So as what we observe in this figure, this one is referring to the similar triangles, no, the two similar triangles, the bigger one and the smaller one. So we have here, we know that the property of the similar triangle is that all angles are congruent, but length of their corresponding sides are in proportion. Okay, so we can use ratio and proportion for solving these given quantities x and s. Okay, so we can now have the conversion for 6.1 meters to 610 cm. That 180 meters is supposed to be 180 cm na siya. Okay, so that is 610 cm. We are also given from the that it is being also illustrated in the problem that we have 120 cm per seconds now, and it was gone when the man is walking away from the straight line. So 120 cm per second. Next, we have here ds over dt. So we are asked to identify also the change in the length of his shadow when the man, no, is walking away from the straight line. So mo nang ds over dt ang ipangita. Okay, so using the property of similar triangle, we have s over 180 is equal to the entire side, no, the longest side. We have x plus s over 610. Okay, then solving or multiplying that one using cross multiplication, so we can now have 610 times s is 610s is equal to 180 times x is 180x, 180 times s is 180s. Then combining like terms, we can actually combine 610s and 180s, so we can get their difference now. 610s minus 180 become 430s. So the remaining quantity from the other side is we have 180x. We can now divide both sides by 430. So from the left hand side, we only have s. On the other side, we have 180x over 430. So at this time, because we are asked to identify ds over dt, so we can get the derivative of this quantity. S is equal to 180x over 430. So its corresponding derivative, we have ds over dt is equal to 80 dx over dt over 430. So that is the corresponding derivative from the above equation. So at this time, we can use now the value for dx over dt, which is 120 cm per second. Okay, so we have here 180 cm multiplied by 120 cm per second over 430. So simplifying, we get ds over dt is equal to 50.23 cm per second. So when the man is walking away from the straight line at a rate of 120 cm per second, his shadow will also change at the rate of 50.23 cm per second. So nga na iyang kung mag-change po iyang shadow. Okay, let us have now the problem number 3. So this one is another type of problem. A spherical balloon is being inflated at the rate of 350 cm cubic per minute. How fast is the radius of the balloon increasing when the radius is 5 cm? So, spherical balloon. Talking about this quantity, 350 cm cubic, per minute is referring to its volume, no? The quantity inside of this spherical balloon, okay, or the space. So we are asked to identify how fast is the radius of the balloon increasing when the radius is 5 cm. Okay, so we are given actually dV over dt, no? The change of its volume, that is 350 cm cubic per minute. Okay, after that, because we are asked how fast is the radius, so uh, the quantity that is being asked in the problem is dr over dt, no? So the change in the rate with respect to time, or radius with respect to time. Then we also have here we are also given this quantity 5 cm as referring to the radius. Then the volume of the spherical balloon is 4/3 pi r cube, no? Okay, so what are we going to do is given formula. V is equal to 4 over 3. Pi r cube is that we have to get its derivative, no? When we derive this given equation, for V, that is dV over dt, then for 4/3 pi r cube, when we get the derivative, we will be using the power rule for getting the derivative, no? Wherein the exponent will be multiplied to its base, then the exponent also will be subtracted by 1. Okay? Then after deriving, we will also write down dr over dt, so that we can now identify this given quantity as being asked in the problem. Okay? So the derivative is dv over dt is equal to 3, because we multiplied the exponent to its base. So we have 3 times 4 over 3 pi r squared, because the exponent is being subtracted by 1, so it become 2 na lang, no? Then as we get the derivative of r cube, we will also write down dr over dt. Then dividing both sides by the quantity 3 times 4 over 3 pi r squared. So we can now have, from the other side, we only have dr over dt, no? On the other side, we have dv over dt over 4 pi r squared, because 3 and 3 is being cancelled out. Okay, so we have 4 pi r squared ang remaining quantity. Then we can now use the equivalent quantity for dV over dt, which is 350 cm cubic per minute. So simplifying, we get dr over dt is equal to 1.115 cm per minute, no? So that is how the radius being, or how the radius increase, no? Okay, with the volume will change at 350 cm cubic per minute. Okay, so I hope that this example will help you, particularly in answering your activity same as this problem.